Alright, so I have drawn the diagram for LSTM models, and it looks a bit complicated, but I can ensure that I'm going through each and every steps here so that you can understand everything. In this particular module, this is one module, this is previous module, and this is successor module. In this module, what is happening? It is taking one input, that is xt. T is the current instance, t minus 1 is the previous instance. It is taking one input xt, it is producing one output ht, and it is creating one cell state, that is ct. Okay. ct is nothing but the memory which we were talking about previously. It is taking input ct from the previous state and output from the previous state, that is ht minus 1. The cell state ct minus 1 is coming as input to this module. All these red sort of things are the kind of called gates or activation functions. Three very important terms here are forget gate, information gate, and output gate. What forget gate does, it decides whether some information to be passed to the next step or some information to be received or not. If the forget gate says, the forget gate will produce some values between 0 and 1 for each and every information, set of informations. If the value is 0, that means the information is supposed to be forgotten at that point of time. If it is 1, that means it's supposed to be received in full. So in this particular case, what is happening? We are taking the input for that particular cell state, for that particular module or that current instance, and we are going to merge it with the previous module's hidden output or output. So we are merging it together in this particular sections. Then we are passing that content through some gate to decide which information to be forgotten or which information to be sent for the next step. So through this Sigmoid gate, it is producing some values or something called ft. Okay. And that information or that gate output will be pointwise multiplied with the previous module cell state, that is ct minus 1 here. As I already told, that this particular gate will produce a sequence of values between 0 and 1. 0 means that information of that particular position should be completely forgotten. 1 means it should be completely transferred to the next step. So that decision is being taken in this particular case. Whatever our forget gate is saying, these particular pointwise operations will produce the similar value, and it will pass those values for the next set of operations for this direction. On the other hand, the same set of information, the concatenated value for xt and ht minus 1 are passed through another gate that is called it here, that is known as information gate. What it does, it decides which content from the current instance and the previous instance output, previous module's output, should be passed for the next step. Okay. So here we have forgotten something. Here we are deciding which information should be passed for the next step. If this gate produces a value of 0 for a particular field or particular information of the current state and previous module's output hidden state. So that particular information would be suppressed here itself. If it is 1, that means it would be passed in full. This gate will produce a sequence of values between 0 and 1, as this is sigmoid. Now, the same information, the summed value, the concatenated value of xt and ht minus 1 would go through a tanh activation function to produce the data or produce the values between -1 and 1. That is basically the current cell state or tentative current cell state. It will have values for every content, tentative current cell state. That cell state would go through a pointwise operations from the information gate IT. So all the values which are said to be non-zero for this information gate would be passed further. It will go to the next step. So the data coming from here, and this information gate is filtering some of those values and saying, okay, these values will be sent partially, these values will be sent completely, and these values will not be sent at all. So whatever the decision and operations taking, it is being done in this particular section, and those values are sent upward. In this pointwise operation, this is summing up whatever the leftover value from the previous cell state and whatever new values coming from this current state. It would sum everything. Once that summation operation is done, it will send those contents for the next step, next modules. The output here is known as the cell state, current cell state. This is tentative current cell state or the possible values. So we have another content left, that is HT or output state or output values. So for that also, the current cell state is going through one pointwise sigmoid tanh operations. So to bring everything within the range -1 and 1. As you know that tanh activation functions or similar functions produce everything in between -1 and 1. So once that data is produced, this is, maybe we can term it as tentative output values, H hat T. The content from xt and ht1, the summed value or concatenated value, will go through another gate. This is also sigmoid gate, similar to this and this. It will produce some output, this gate, that is known as OT or output gate values. These values will decide which information from these tentative output values should be sent as output or which information should be suppressed right away. So once this pointwise operation is done here, the output would be produced, and one portion of it, basically those are same copies, it's just copy is happening here, and whatever the output is coming from these operations, it will be sent for the next step, and it would be the output for the current cell state. Okay, so this is the whole operations for the LSTM model. It is maintaining one cell state for the historical memories, like which or what all critical informations it is carrying there. The cell state is first going through a forget operations. Here it will decide like which information from the previous cell states we should carry further or which information we should forget right away. In the next step itself, it is new informations are being added to the cell state. and finally those cell states are sent to the next step. All these gates would be decided on the basis of the current input and previous output. So these operations will decide what information to forget, what information to keep still maintain. This gate will decide which information to be sent for the next step, which information from the current input content should be sent to the next step and should be added to the cell state. And these are the values for the cell state or tentative cell state. Finally, the output gate will decide which information should be produced as output or which information should be suppressed right away. And the tentative output is being prepared from the current cell state through the tange operations. This is not a gate or this is not activation function, this is just simply tange operations. And it is producing the output. The data is flowing through this side, and this will also get this input and this input, and it will perform the similar operation like this block, and it will produce again another output, maybe ht plus 1 and xt plus 1, taking one input, producing the output and producing another cell state. This is the whole operation for LSTM. We are going to implement this LSTM model also in our next lab sessions. Once we have tried with the simple RNN functions, then we'll try this LSTM. Then we'll have many versions of it, like bidirectional LSTM, stacked LSTM, similar sort of things. And this is one of the version of LSTM, and they are continuously being developed by several scientists and engineers, in the sense like they are being tried, different gate options are tried. Another kind of flavor which I can recall at this point of time. So this is not a traditional LSTM model, but this is traditional LSTM model. The new things which I am going to explain here will be maybe different. So what they're doing, rather than deciding on the previous layer's output and this layer's input to decide which information to forget and which information to to include. So they consider the previous cell states also to decide this thing. Like simpler term, they take this input and they include in this gate operation, forget gate, and they include this thing in this input gate also, and possibly the output gate also, giving the same values, similar sort of things. Okay, so this is another version, and they are considering the previous cell state also while deciding which information to forget and which information to add in this cell state and which information to produce as the output for the next layer. Similar sort of things. Another simpler version of similar concept is known as GRU, Gated Recurrent Unit. So that has a little different architecture, but that's supposed to be the simpler than this. Okay. So what I can do, if you want, I can also explain the arithmetics of these all operations. Okay, so let's alright, so let's skip that portion, that mathematical section. Let me draw the diagram for GRU, and then I will quickly explain like how it is working. But that's supposed to have the simpler architecture than this one.